So again, just to reiterate, the volume is just the measure of all the space inside of a 3D object, just like area is. The only difference between area and volume is volume deals with the space inside 3D objects. Area is 2D. So if you'd like, you can even make a note to yourself on the side that area is for 2D objects or 2D space. Volume is for 3D space. That'll help kind of differentiate what you need to use, because what we're doing here is we're going to be building from the units for area up to the cube units for volume. Let's get started with a couple of examples below. So for number one, we have what's called a rectangular prism. So if I have a rectangular prism, that means I have to use the formula V is equal to base times height. Well, in this case, if I look at my prism right here, this whole rectangle that's on the bottom of my prism is my base. I'm going to make a note off to the side for myself that here my base is equal to 4 centimeters times 12 centimeters, because I'm multiplying to the area of that bottom part of my prism. And if I plug that in, 4 centimeters times 12 centimeters, you get 48 centimeters squared. And that right there is key. You want to make sure you include that square, because that's what helps us build up to the volume. So now all we have to do is plug in our base that we found into our original volume formula. So right now you have the volume is equal to 48 centimeters squared. We have to multiply it by our height. In this case, the height is talking about how tall our 3D object is. And we can find it by the measurement that's sitting on the vertical side. In this case, that means that our height is 8 centimeters. So now what you're left with is just a simple algebra problem. All you have to do now is just multiply 48 by 8. 48 times 8 gets you a solid 384. If I write that down, 384, I have to make sure to still include my units. In this case, I'm multiplying centimeters squared by centimeters. If you have units that are squared being multiplied to a normal unit measurement like this, you have to write it as centimeters cubed. It's like we're counting up with it. So that would be our volume for a rectangular prism. We're going to apply that same reasoning to the triangular prism here. So this one's a little bit trickier to see. This one's kind of, it's sitting on one of its sides right here. But remember what I talked about above. A triangular prism is called that because that means its bases are the triangles. That's what makes it a triangular prism. Prisms exist all around, but what makes them unique to be triangular prisms, rectangular prisms, are these unique shapes on the top and bottom. So for here, that means when I write out my formula again, that V is equal to base times height, my base is going to be the triangles right here. So it's just going to be 1/2 the base of my triangle times the height of my triangle. And when I substitute in everything, I can see that the base of my triangle is 6 and my height is 5. And I'll just plug them in just like that. My base is 6 centimeters and the height is 5 centimeters. And if I plug that into my calculator, 6 times 5 times 1/2. And the reason why it looks like 1 divided by 2 is those fractions are considered division. So this is how you have to write it in your calculator especially on your phone if you want to get an answer like this. If I plug everything in, you get a very beautiful 15. And again, just to kind of hit on this one more time, when you're multiplying two units together like this, where there is no exponent, we're going to add them together. So if this one is centimeters to the first power and centimeters to the first power, if I add the 1 and the 1 together, you get centimeters squared. So that right there is my base. I'm going to plug it back into my volume formula up top. So I have 15 centimeters squared. And my height here, even though it's laying down, my height is listed at 3.5 centimeters. Same thing, we're just back in a simple algebra problem from here. So we do 15 times 3.5. You're going to get a decimal, but it's a real nice one. You're left with just a 0.5 there. So we're going to write out our answer formally as the volume is equal to 52.5 centimeters. And again, we have centimeters squared being multiplied to centimeters. So the important part here is that we have to add the exponents together again. This is centimeters squared plus centimeters to the first power. So your final units should be centimeters cubed. Just like that. We have a couple more volume problems we're going to go over, and then we're going to hop into word problems because those will come up on your test. So for a cone, the cone has a very specific formula. It is volume is equal to 1/3 pi r squared times the height of your cone. And I can see right here that my height is 18, and my radius is also listed to be 7. So since I know all the necessary information, I'm just going to plug it in first. Rewrite your equation with all your known information, which means it should be V is equal to 1/3 pi times 7 squared times 18. So again, all we did is we took our known information from the picture and plugged it into our formula so we could start solving. And this does look a little messy. We have a bunch of numbers being multiplied against each other, and actually one of them being raised to the power of 2. When you have something like this, your first priority algebraically is to solve the exponent. So first things first, you have to plug in 7 times 7, or 7 squared. Because remember, that squared is just telling you how many times to multiply 7 by itself. When you do that, you get 49. I recommend rewriting the equation just to kind of get into that habit. So volume is equal to 1/3 pi times 49 times 18. Now we have a straight multiplication problem. And I recommend to just plug it in as such. So I have 1/3 as my fraction up front, so I'm going to put in 1 divided by 3 and close it to start with. Next, I'm multiplying to pi. You have two ways to approach this. You can use it to where pi is 3.14 and round up, or you can use the one in your calculator on your phone. Either one should get you very close to what the answer is. So I've done 1/3 times pi. Now I multiply by my 49. And I ended off by multiplying to my 18. So if you look at my phone, it's definitely a lot messier. This is typically why in math we don't put these little X's, because it makes it look a little gross. It's hard to kind of look at that and see what's really going on. But it's the same expression back and forth. It may look different from what's on my paper. It's still the same statement. And if I plug it in, you get 923.628, and it goes on forever. The rule is when you're doing these problems, round up to that 100 spot right there. So that means my volume here is 923.628. But if I round to 100, I need to round up knowing that that number to the right of my 2 is higher than 5. And if I round up, that means your final volume should be 923.63. Because again, when you round up to this part of your answer, you need to consider the value to the right of it. 5 and up means you get to raise this number up by 1, just like we did here. Anything below 5, you would leave it by itself. And that is how you find the volume of a cone. Now the pyramid is what we're ending with for these diagram problems. And the volume formula is the same as what we've been working with. It'll be volume is equal to the base times the height. Now the base here is not a square. We have 2 different measurements. We have 12 feet and we have 6 feet. So that means we're dealing with a rectangle. So when I plug that in, that means my base formula is the length times the width. So I have 12 feet times 6 feet. And 12 feet times 6 feet gets us 72. 72, and again, we have feet times feet, so we have to make sure to include feet squared right here for your base answer. Now that we found our base, we can plug it back into our volume. So volume is equal to 72 feet squared. And now we just have to substitute in height. And again, the height is just talking about how tall the pyramid is. And that's listed right here. Your height for the pyramid is 15 feet. So substitute in that known value for the variable. And now you just multiply through. I don't recommend doing this on paper. When it starts to get to these type of numbers, it gets a little messy and harder to keep track of. So I would actually just use your phone calculator and do 72 times 15. You'll get a really big number. You'll get 1,080. The volume for the pyramid is equal to 1,080 feet cubed, because again, feet squared times feet. That's all you have to do for these. A lot of these diagram problems when it comes to volume is just plugging and chugging. It's more algebra than it is geometry because we're trying to find that numerical value of how much space it takes up. So the next one we're going to be working with are some word problems. And again, you will see a couple on your test, but let's kind of get used to them and how they might be written. So for number 1, we're told that we have to find the volume of a shoebox that measures 12 inches by 10 inches by 5 inches. Now, this one's a little bit hard to think about, but remember what a shoebox looks like. A shoebox is a rectangular prism. So just like when we were doing our other problems early in the year, I recommend drawing it out. Get creative with it. If you want to, you can put a lid on it, throw some shoes in there. Anything to kind of help you visualize the shoebox. In the next step, we have all these measurements. Well, all these measurements actually represent something. This represents your length, this represents your width, and this represents your height. So these all represent something very specific about the shoebox. This is telling me that my shoebox is 12 inches long. This is telling me that it's about 10 inches wide. And that my shoebox has a height of about 5 inches. So now that I have that picture drawn out, all you have to do is just multiply straight through. Your volume is equal to 12 inches times 10 inches that would be your base of the shoebox, times 5 inches for your height. And if you look here, this formula that we just wrote, it's actually about the same thing as the one in your instructions. Because whenever you see these written out for things like rectangular prisms or square prisms or cubes, this is your volume equation. Because again, we're following that length times width is your area formula times the height of the prism. Now if I multiply it out, I have, well, times 10 times 5 to get me a full value of 600 inches cubed. And that'd be it. That's how you get volume for the shoebox. For the next one, on number 2, we're asked how much air we would need to fill up a basketball with a 6-inch radius. So if I have a basketball, it's 3D, so students already filled, and we're just trying to figure this out. The radius measures to be 6 inches. Well, the volume formula for a sphere is volume is equal to 4/3 pi r cubed. The only missing value you have in this formula is the radius, but it's actually given to you right here, directly in the problem. So the only thing you have to do is just substitute in that 6 to the equation, which would mean we have a formula of 4/3 pi times 6 inches cubed. Now I know this can still be a little confusing on how you plug these in. So I'm going to show you one time here. Once more, remember that fractions are just division. So all we have to do is close them in parentheses and write 4 divided by 3 and close it on the right side. This still, again, represents that fraction, but you want to make sure you close it to where we make sure this is all one value. Calculators are not smart enough to see that this is supposed to be your fraction. So if you leave this open, then it'll start doing crazier things if you want to do a full equation like we're about to do right now. We have 4 divided by 3. I'm going to multiply that to pi, and I'm going to multiply it again. Now this next step here, we have to cube our 6. There's a couple ways you can do this, but the easiest way to guarantee that your calculator will know what you need is we do another set of parentheses. So do your parentheses, type in 6, and then for Android, you do have something that looks like a caret on the bottom. So this one right here, with the little arrow going up. You would click on this to raise it to 2 or to 3. For iPhone, I think you guys have something where it's the variable x, and then you're going to have a variable for your exponent. Click on that, and you should be able to get a choice of what you want to raise your number to. If you do not have that option, remember that an exponent is just telling you how many times you're multiplying the base by itself. So if I didn't have this exponent, I could just write 6 times 6 times 6, and it would still give me the same answer. And if I click equals, that'll get me my full volume. So your volume here would be equal to 904.778 inches cubed. And like normal, I want to round up to the 10th. So if I want to round 7 up, I have to take a look at 8. 8 is definitely bigger than 5. So since 8 is greater than 5, I have to raise 7 up to the nearest value, which means my volume is going to be 904.78 inches cubed when round up to the nearest 100. Just like that. Okay. So for number 3, let's think of our shortcut. So a fish tank, right? We're talking about a fish tank that is 12 feet by 5 feet by 9 feet wide. What is the volume of water in the tank? So notice how this one is not written in the same way as number one. We have our wide measurement at the end. So let's draw it out. We have 12 feet as my length and 9 feet as my width. So I can only assume that the 5 feet is supposed to be my height. This is why I do recommend you draw these out, because if you don't draw these out, it's a little hard to see what they mean when certain problems are written differently. So this is my fish tank. That means I have a base of 12 by 9. Let's write out our volume equation. Volume is equal to your base times your height. If my base is 12 times 9, that means I have 12 feet times 9 feet times the height of 5 feet. Because again, the base is just the length times the width to get that measurement. Now you could take this in steps and do your base measurement first and then multiply it to your height. But you will get the same answer if you simply just plug it in. Because we just have a multiplication problem straight through. So the only thing that you'll need to do is just multiply 12 times 9 times 5. If I multiply that all together, you'll get a volume measurement of 540 feet cubed. Because again, when we're talking about volume, we need to cube our units. And that is the volume of the fish tank. The next two are a little bit more difficult, just because the wording is a little bit strange. It's the same concept again. So for number 4, you have 2 soup cans in the cabinet. In can A, I'm going to draw it in pink. This will be my can A. So can A has a height of 5 inches. And we draw it next to the vertical height right here. And it has a radius of 2.5 inches. Now can B, I'm going to draw can B in blue. Here is can B. This one has a height of 4 inches and a radius of 3 inches. And you have to be able to say which can has the most soup in the can. So what this is asking for is which one has the bigger volume, because that's going to have the biggest or the most soup in that can if it has a bigger volume. Let's start with can A. So for can A, we have to use our volume formula of pi r squared times the height of the cylinder. Can A, we know that the radius is 2.5, so we'll do pi times 2.5 inches squared, and then we have to multiply by our height, which is 5 inches. And again, you can take this in stages. There is no need for you to multiply straight through. You can do pi times 2.5 inches squared times 5. Do this all at once. To kind of illustrate that point, I'm going to do it all at once again for can A, and then for can B, I'll take it in stages so you can see why it works. So for here, I'm going to do pi to start times, and I'm going to do parentheses just to keep 2.5 as its own value. Parentheses, 2.5, and I'm going to make sure to square it. Notice how I close those parentheses. I want to make sure it's considered its own value in the calculator. And then to end it, I'll multiply by 5. If I click equals, you get a big nasty decimal. Write it up to the 7th, because again, we ended our 100th spot, and since the 4 is less than 5, I can just write my answer as 0.17. And this will be inches cubed. Now, for the next one, for can B, we're going to use the same volume formula. V is equal to pi r squared times height. And we're going to plug in what we know. We know that our radius is 3 inches squared. And we know that my height is 4 inches. Now let's take this in stages. 3 squared gets me 9 because it's just 3 times 3, which means that I have pi times 9 inches squared times 4 inches. So now let's do pi times 9. If I multiply pi times 9, you get 28.27 inches squared. You just have to end it by multiplying by 4 inches. If I multiply that by 4, I know that my volume for can B is equal to 113.10. And I'm rounding up because I know that 9 is there. So if that 9 is there, that means they have to round up a 0 to 1. And then the inches cubed. So through this math, we saw that can B actually has quite a bit more in it than can A does. Let's take the same concept and finish it off in number 5. So number 5, we got a little bit of a bet going on, seeing who has the biggest room. So we have Julia's room, which will be drawn in green, and Sophie's room, which will be drawn in orange. And since rooms are typically rectangular prisms, I'm going to draw it as such. Again, the easiest way to draw rectangular prisms is to take the mirror images and stagger them like this. And all you have to do is just connect the vertices together to get your 3D image. Now, Julia says her room is 8 feet by 9 feet by 9 feet. Sophie, she says her room measures to 10 feet by 8 feet by 9 feet. We have to see who has the bigger room. So these ones are nice and easy. Remember, rectangular prisms have a straight multiplication problem. We're just multiplying the base, which in this case for Julia's room, we're multiplying 8 feet by 9 feet, and multiplying it by the height of 9 feet. So you can write this, the volume of this room, as 8 feet by 9 feet by 9 feet. And just plug it into your calculator on your phone like this. All you have to do is do 8 times 9 times 9. If you click equals, you get a volume of about 648 feet cubed as your answer for Julia's room. Now for Sophie's, the volume is equal to, again, same thing. We're multiplying our base by our height. And our base in this one is 10 feet by 8 feet. So we'll plug in 10 feet by 8 feet. And multiplying that by the height of 9 feet. Just like for Julia's room, we're going to plug it straight in. So let's do 10 times 8 times 9. Just like how I have it written on my paper. And I get that the volume is equal to 720 feet cubed. So using those formulas, we found that Sophie has the bigger room. And that's how you do volume. Again, a lot of it is just simply plugging and chugging and being a little bit careful about how you round up your numbers in the quiz. this is the lesson you guys have to learn. So if you have any questions at all, let me know. But other than that, once you have this, you're ready for the test. So I hope you guys have a wonderful rest of your day and let me know if I can help in any way.